All right, so this brings us back to rain droplet size and shape. And as I mentioned, as the rain droplet itself drops through the atmospheric layers, it will retard or pull on its sides and pull apart. And this is another way that I can get a pretty solid rain droplet that will come out of a cloud. And if the air that is retarding or dragging against the droplet as it drops through the atmospheric layers actually pulls that rain droplet apart, I can end up with mist. So I can see a misting, which creates a very low level of visibility as little droplets get pulled into smaller droplets that are a little harder for gravity to drag back down to Earth's surface. But this all takes place outside of the cloud. So I've now come out of the cloud and I'm falling down as I come through. Another key type of precipitation is hail. And I'm going to show you a quick image of hail formulation and just mention that hail is something that requires a cumulonimbus cloud or something bigger. So I can formulate hail in cumulonimbus clouds. I can formulate hail in tropical storms, thunderstorm clouds, and hurricanes. Those are all common places that I can formulate clouds. I need a very tall vertical cloud to do it in, and that is because I need a good strong updraft to hold the ice crystal in the cloud long enough for it to have so much accretion, so much rimming process occur that I create a very large hailstone. From there, I also need a good strong downdraft to pull. So I have to be moving through the cloud regime. I need a good strong downdraft to pull the hailstone down and out of the cloud at speeds that it will reach the ground before it would melt, melt or become rain as it's coming down, allowing it to be quite sizable. And here's some examples of hailstones. Now, one of the key things that makes a thunderstorm as opposed to just a cumulonimbus cloud is a vertical cloud that can still have ionic separations, but a thunderstorm cloud has a clearly defined updraft and a clearly defined downdraft. That's how I know it is a thunderstorm cloud as opposed to a cumulonimbus cloud. So there you go. And we'll cover that more when we get into tornadoes because it requires at minimum a thunderstorm cloud to make a tornado. So, all these things fit together. This is a great image because it retarded on the way down, pulling apart, or this might be sawed in half. I'm not sure. But either way, I can see the rimming process. I can see the different layers within the cloud itself that the accretion took place, right? That they stuck to the ice crystal, kind of forming almost like tree rings, but on a hailstone instead. We already went through what is sleet, but once again, the cloud, snowflakes, right? So I have nice clean ice crystals, melted, refroze. Freezing rain freezes on contact, and there are amazing videos if you are ever YouTube bored. Look up some of those crazy freezing rain videos where you can watch like time lapse of somebody's car just end up getting solidly frozen into like an ice block because the car is very cold and the rain is falling and it's freezing on contact. One of the ways that we can measure the amount of precipitation that's coming down and locating itself on the ground surface is through a rain gauge. A rain gauge has a standard opening at the top, and the area collector will be a 1/10 of the collection region. And then I can measure how much water drops down into the rain gauge itself. This is an example of the rain gauge, and I can see that there is a pivot that allows it to dump into the bucket if it gets too full, right? And that allows me to create measurements. Obviously, rain gauges are not a foolproof way to determine how much water vapor has fallen from the sky and made its way down to the surface. And there's lots of reasons for that, multiple inaccuracies. And one of the main ones can be just evaporation, right? Evaporation could be taking place, and that would create a reduction in the amount of water vapor present. There are other things that can occur, as well as failure within the system itself or failure within the tools themselves that creates kind of an inaccuracy. So there's a pretty good grace level of range on how much is present. We kind of give ourselves like a 1/4 inch estimate up or down, where we can say it's plus or minus a 1/4 of an inch of rain difference on our current precipitation monitoring methods. There's another way that we tell rain, and this has to do with Doppler radar feedback. As the Doppler radar feeds back, I can then talk about it in forms of visibility. And that allows me to gauge out how much precipitation is making it to the ground, and how thick or how visible my process is. Snow measurements are done very similar to rain gauge, where I'm taking a specific region and I'm doing a ratio over that region. So I'm taking kind of like a square and I'm measuring down the height at that square. Cloud seeding. Cloud seeding is a human-induced rainstorm. This is one where we will go up into a place where there is a lot of moisture, so there's a lot of cloud formation, but there's not a lot of condensation nuclei for the clouds to stick to. And we will actually specifically pepper the cloud with ice crystals or condensation nuclei to stimulate cloud fall to create rain. And we can see an artificial form of upper atmosphere cloud seeding occur when we have a plane fly by and it leaves that streak, that contrail. If the water droplets stick readily to the contrail and persist long past when the plane flew by, so we're talking about like 2, 3, 4 hours later, they basically formed a cloud on that contrail, I know that that upper atmosphere is incredibly moist right now, and I basically made an artificial cloud. Cloud seeding is no guarantee that it will cause rainfall, because I have no guarantee that they will exceed the size needed for gravity to pull it down to earth. But if it's fairly moist in the lower layer, so in this strata region of my stratosphere, so my lowest layer, or not stratosphere, my troposphere. So my strata layer of my troposphere, which is my low-level cloud layer, if I can get fairly good moisture at my low-level cloud layer and I can get a good cloud seed going, I can get at least some moisture to come down to earth, but not necessarily in that fabulous heavy rain that we would be looking for. Another problem that occurs with the liquids coming out of the sky is flooding. Flooding has become a bigger and bigger issue in the United States and more common, especially as we're seeing a dichotomy in our climate where we will see incredibly long periods of drying. So I will end up with cracked, dry soil that becomes compacted. So it has no space for moisture to actually accrete or be absorbed into. So the ground is no longer like a nice sponge that can absorb the earth, so that when the rain does finally fall, it hits the Earth's surface and has nowhere to go except for to run off. And that runoff process can cause these floodings as they occur all over the United States. And we're just going to hear more about it. It's a huge issue that's going to continue and persist. So on that note, I'm going to actually flick over to a fun video and explain to you a fun form of not rain, because it never reaches the ground, but a process called virga. All right, so this is a process called virga. And virga is when the water, and it could be snow too, and we call that a snow streak or fall streak when it's snow. But it's when the liquid, whether it be in its solid or liquid form, leaves the lifting condensation level or the base of the cloud, and so it begins to more or less rain out of the cloud. But as it's coming down, it dries out or evaporates on the way down, creating what's called virga. So it's basically raining up here in my image, right? Up here it is raining, but down here it is not. And this is incredibly common. You can see this all the time. I can't even tell you how many times I'll look up at the sky and I'll see these streaky kind